Hey, what's going on? Today we're going to do a couple new lessons. We are going to graph cubic functions and also cube root functions today. What I want you to do is attempt the do now. You know how to eliminate radicals and exponents, so I want you to think about how you might get rid of the cube root and the exponent of 3 and isolate those variables and get the values. When you are done, please press play and then check out the video as we go through the solutions. All right, awesome. All right, coming to the first one now, just real quick, you know that to isolate a cube root, the opposite of that is to cube it. When you do that, these are inverse operations, so they will actually eliminate each other. So what we're going to do right off the bat is we are going to cube both sides of this equation, and we're going to get x equals 27. Pretty easy for the first one. Let's move on to the second one, where we have the 2 in front. Now, what do you think I need to do with the 2? I need to divide it out. So I'm going to have cube root of x plus 1 is equal to 3. Now is where I want to take my exponent of 3 on both sides, and I'm going to get x plus 1 is equal to 27, and a final answer of x equals 26. Going on to number 3. In this case, I need to do the opposite of cubing a number, which is going to be cube rooting a number. So x is going to equal the cube root of negative 125. Now you have to ask yourself a question. What is the cube root of negative 125? And it is negative 5. Because negative 5 times negative 5 times negative 5. When you take an odd index of both sides, you do not need the plus or minus. You do not need the plus or minus. That's only when you take the even index of both sides of an equation. All right, going on to the last one. The first thing I want to do is I want to eliminate that plus 1. So I'm going to bring down the x minus 2 to the third. And that's going to give me an 8. And I'm going to get x minus 2. Again, to get rid of that 3 exponent, I need to cube root both sides. So I'm going to get x minus 2 equals the cube root of 8, giving me x minus 2 equals 2. And lastly, x equals 4. So hopefully you understood those. That's how you solve cubic and cube root equations. What we are really interested in today, though, is how are we going to graph cubic functions and also cube root functions. So the first thing I would like you to do is go into your calculator and type in y equals x to the third so that you can fill in the table of values. And also, we're going to hit the graph button and take a look at the picture anyway. So go ahead and just do that, and then we'll move on. You also need to know that cubic functions have a degree of 3. So that's important as well. So go ahead and take a minute, fill in the table of values, and then we'll get back to this here together. All right, good. Negative 2 cubed is negative 8. Now you might say, can I just do this in my head? Of course you can. Please do it in your head. Negative 1 to the third power is 0. Negative 1, 0 to the third power is 0. 1, 1, and then 2, 8. And what we're going to do is we are going to come over to the graph here, and we're going to graph these points. All right, the first point we want to graph is negative 2, 8. So negative 2, 8 is going to be fairly low here. So let's find that location. If I can get this pen to work. Awesome. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8 is going to be a point right down there. Then we have negative 1, 1, 0, 0, 1, 1, and 2, 8, 2, 1, 2, 3, 4, 5, 6, all the way up here. Now the first thing, what do you notice about this function? The function itself is a little bit of a curve. So it kind of comes down through here, curves up through the middle points, and at the end, your graph should look something like this. And that is what a cube root function looks like. So cube root functions are kind of like a little snake. They kind of snake through those closest 3 integer points. And so we're going to label this as f of x equals x cubed. And that's our first cubic function. Let's talk about domain and range for just a second. You're going to love this because the domain and range of cubic functions is all real numbers for both the domain and the range. So that makes our life very easy. Unlike square root functions and absolute value, they're both the same, so we're just going to keep it like that. Unless you're given a restricted domain, keep it the same. Now, real quick, you might say, okay, I see that this goes forever down and forever up. I can clearly see that, so the range is clearly all real numbers, but it doesn't look like it's going forever left. I could see why you would say that, but here's what you have to know about this function. As it snakes down, it's actually continually going left, but just at a very, very, very steep angle here. And that's why. But it will indeed go left forever, so just keep that in mind. All right, again, just like before, we call this the parent function, okay? The parent function is the simplest version of what a cubic function can look like. So what we're going to do next is we're going to go to the next page. We're going to graph 2 cubic functions that are not the parent function, but they should have a very similar shape to them. They should have that kind of snake shape to them. First thing I want you to do is go to your table of values and fill in a few good points. Now remember, always choose integer points. You don't want to try, if you can avoid it. So go ahead and put this in the table of values into your calculator, and then fill out a table of values. I'm going to use -1, -6. Then I'm going to use 0, 1. Then I'm going to use 1, 2. Then I'm going to use 2, 3. And then 3, 10. So what I want to do at these points is I want to come off to the graph now, and I want to graph them. So let's graph these points together and see what they look like. So we have -1, -6. That's going to be right there. We have 0, 1. We have 1, 2, 2, 3. And then we have 3, 10. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. All the way at the top here. All right, so what I need you to do is gently curve your line through this point. So it's going to come up through the points. It's going to snake through the middle 3 points and then go all the way up. It's going to look something like this. Make sure that in this middle section, you kind of snake through them, kind of curving through them, and don't do a straight line. It's not linear there. It's kind of always kind of curving and bending. And as always, we are going to graph this with the function named on it. So again, right here at the top, you can put the name of the function, which is x minus 1 cubed plus 2. All right, let's try the second one together. The first thing I'm going to do is I'm going to create a table of values. You can get the table of values by plugging this directly into your y equals. I'm going to get -2, 19, -1, -2, 0, -5, 1, -8, and 2, -29. Now, the first thing you notice is that this is not going to graph all the points because they're too far. That's okay. We are going to do the best we can. So -2, 19, I'm going to leave off the graph. That's too high. You could also renumber your grids if you wanted to as well. But I'm going to just plot the ones that we can actually do here. So -1, -2 is right here. Let me get my pen. -1, -2 is right there. -0, -5, 1, 2, 3, 4, 5 is right there. 1, -8. 1, 2, 3, 4, 5, 6, 7, is right here. Now, those are your three inner points. Now, negative 2, negative 29 is really low. So what I want you to do is, to the best of your ability, try to snake this function kind of through the points. So kind of through these middle points, and then we're going to shoot way up towards 19 or whatever that was. Yeah, 19. And that's going to be our kind of snake function. It's kind of stretched out really far, a little hard to see. But let's put our equation there, negative 3x to the third minus 5. Again, if you were to renumber these grid lines, you'd probably get a better picture of that. All right, let's move on to our second type of function. The second type of function is the cube root function. It involves anything that has a cube root. So real quick, we're going to graph this parent function, the most simple version of a cube root function, and I want you to do the table of values, fill those out, and then we can get started. Plug that in your calculator. You can always hit the graph button and take a look at what this picture will look like. But I told you that these are very much related, and you will see that. Cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1. 0, 0, 1, 1, and 8, 2. And what we're going to do is we are going to graph these points and see what the shape looks like. So take out a pen of some sorts. We are going to graph all of these points here. So the first one is negative 8, negative 2. Right there. Negative 1, 0, 0, 1, 1, and 8, 2. Right there. Now this one is also going to snake through, but at a slightly different angle. This one comes from the side this time. So we're going to come from the side here. We're going to snake through those middle 3 points, and then we're going to shoot off towards that last integer point. Again, I'm calling these the integer points. You know, along this line, there are infinite amount of points that are decimals, rational, irrational. So you need to keep that in mind. We're just graphing the integer points because they're easy, and we will say g of x equals the cube root of x. And we have labeled our graph, and we are done. All right. Let's go back to the domain and range. We said that the domain and range is going to be all real numbers for these, which is awesome, again, because it makes us not have to think all that hard, because this is kind of the same answer every time. You might say, okay, I can see that it clearly is going forever left and forever right. So the domain is clearly all real numbers. It doesn't look like it's going down, but the same argument we used before, it is forever going down, just at a very slight angle. So if you went infinitely far, you would go infinitely down. So that is why the range is also all real numbers. All right, let's go on to our last 2 examples here. Of this cube root function. What I would like you to do is plug the functions into your y equals, get a nice table of values of nice integer points, graph the shape. Again, it should look like a snake, but now it's on its side as opposed to going up, and then we will go from there. All right, take a minute, pause the video, get a nice table of values, and then we can finish this up. All right, so the x, y table of values that we are going to use is negative 5, negative 2. Then we're going to use 2, negative 1. Then 3, 0. Then 4, 1. And now lastly 11, 2. I'm not sure we'll be able to fit that. We'll go right off the graph a little bit, though. It's fine. So let's come to the graph and let's plot these points and get a picture of what this looks like. So what's the first point we're going to do is negative 5, negative 2. Right there. Then we have 2, negative 1. Then we're going to have 3, 0, 4, 1, and 11, 2 is going to be kind of like right there off the graph. That's okay. All right, so what we want to do is we want to snake this function through the points. Don't go too much past any points. That's kind of a general rule, just because you'll end up kind of shooting it off in a direction it really doesn't go. And so that function is y equals the cube root of x minus 3. Let's get that 3 in there. All right. So that function is done. Let's go on to number 2 here. Let's first start off with our table of values. The table of values we are going to use of all good integer points is going to be -8, 5, -1, 3, 0, 1, 1, -1, and 8, -3. So I'm going to go ahead and start plotting these points. We're going to start with -8 and -5. If you want to pause the video and try these on your own, you may. 1, 2, 3, 4. So -8, 5 is right there. -1, 3 is here. 0, 1, 1, -1, and then 8, -3. All right, so we're going to end up drawing this graph through these points. We're going to kind of come from this angle. We're going to snake down through these points and then come across here. All right, and then that's the arrow there. And our label will be -2 cube root of x plus 1. All right. So that is what that one looks like. Again, guys, you can please check in the calculator what these look like. They should give you that picture. All right, let's wrap this lesson up with what's the relationship between cubic and cube root. They almost look the same, don't they? They have very similar features, but cubic and cube root are slightly different, and I want to just show you why they're different real quick. All right, so first thing, take out your calculator and just fill in these table of values for both of these functions, and then we'll get going here on this last conversation. I do have to just go back real quick, my apologies. The domain and range of all these functions are all real numbers. I'm not going to go back and fix all of them, but you should have had that there. It's the same thing for all these, even the previous examples we did. Domain and range is all real numbers for these guys. You'll see on the answer key on the website, they are all listed for you. So that is that. All right, let's fill in this table here together. -2 is going to pair with -4, -0.5, 0, 0.5, and 4. Again, in your table of values, you might need to change your table set to go by halves in order to see this point, the 2 points on the side with the 0.5. And then the other table is going to be -2, -0.5. Then you're going to see 0, 0, 0.5, and lastly 2. Now, what do you notice about these? The relationship looks like the points are just flip-flopped. -2, -4 becomes -4, -2. 0, 0 stayed 0, 0, but 1.5 became 0.51. And what you're going to notice is that these input-outputs, they switch places. Let's take a look at the table of values here and then what they look like in a graph. So let's graph these points together. We're going to start off with, let's do f of x first. So -2, -4, -1, -0.5, 0, 0, 1, 0.5, and then 2, 4 is here. So that is going to snake through the points kind of like this. Snake through them. I always say snake through them because that's kind of what they do. Best way to describe that. And then we're going to graph g of x here, which is negative 4, 2 up here. Negative 0.51, 0, 0, 0.5, 1. Oh, that's negative 4, negative 2. That is my fault. Negative 4, negative 2. So it's down here. Negative 0.5, negative 1. Then we're going to have 0, 0, half 1, and 4, 2. And that line is going to snake through very similarly to the other one. So we're going to kind of come up through here and kind of shoot off that way. So again, what do we notice? We notice that they have the same general shape, but they're just in different locations in which way they are pointing. So this was our f of x, this was our g of x, and they are very similar. So we call these, the table of values is switched. We call these inverse functions. When this happens, these are called inverse functions, which isn't surprising because cube root and cube are inverse operations. So when we graph them, they are called inverse functions. All right, and that wraps up this lesson. So I hope this was helpful. If you have any questions, please ask. And again, as always, practice, practice, practice. This is the best way to get good at this stuff. All right, see you next time.